getting to the last bit, and we were talking about the midterm theorem, right? Who wants to remind us? Does anybody remember what the midpoint theorem actually tells us? I'm going to give you half of it, and I want to see if anybody else can finish it for me. Okay, Kwane's hand is already up, so I'm assuming he's going to tell us what's happening over here. Kwane, what do you know about the midpoint theorem?
The midpoint theorem, what I know about it, it tells us about the gradients of the shape.
Good, okay. Sometimes it tells us about the value of the shape, but okay, so we know that midpoint has something to do with a line that cuts the two other sides of my triangle in the middle, right? So this line, what do we know about this line? As soon as it cuts the other two sides in the middle, what do we know about it? What does it tell us about the third side?
That's the side A, B, and with AC equal to each other.
Good. So AE and EC will be equal to each other. Good. What about AD and DB?
Oh, they also equal.
Good. They'll also be equal to each other. Right. What do we then know about this line DE and the line BC? What do we figure out about them from the midpoint theorem? That they are? Help Kwane out, guys, in the chat. Do you remember? No. Okay, let's see if Luyanda can. Do you think Luyanda can fill in the gaps for us? Because you're correct about those two statements. Let's see if Luyanda can fill in the rest for us. Okay.
Since the line AD and BC parallel to each other.
They're not equal. Nope. Nope, they're not equal. If you have a look in the chat, everybody's telling us what we need to know. Okay, they're telling us that line DE and line BC then become parallel. They're parallel. And then DE and BC also have, the lengths of these two sides also have a special relationship. Okay, they tell me that DE is half the size of BC. So if DE is X, if DE is X, then BC needs to be double of X. It needs to be 2X. Okay, so everybody's with me there. Thank you, Kwane, for that, for reminding us that the other sides will also be equal to each other, 100%. Okay, we've learned about this for a while now, and we've done some examples on the midpoint theorem. Let's see if we can use these in an example. All right, here is the example, and the instruction here reads that, it reads find the values of X and Y. Okay, so there's some work to be done in this particular question. Okay, there are a couple of things that we need to do before we get going. We first have to state certain things. Okay, David, 100%. But you can say that. But before we even get there, David, what do we need to say? Oh, David was talking about the one above. Let's look at what they've given us over here. They've given us triangle PST and triangle PQR. Okay. So we're going to have to figure some things out here. Let me start with the statement. I'm going to say QR, Luyanda beat me to it. I was about to, Luyanda. Okay, good. QR is parallel to ST. What is my reason, guys? What is my reason for the statement? Okay, Luyanda has already come to the conclusion that we can all come to in this case. Why can we say that they're parallel? Yes, Luyanda.
Because of the midpoint theorem.
Beautiful. Yes, because of midpoint theorem. 100%. Luyanda, can you tell us anything else? Okay, now you've told us that QR is parallel to ST. Is there anything else that you can tell us? Anybody? Also the I'm going to tell you now, the reason is going to be midpoint theorem. Anybody else got any idea? Okay, remember the midpoint theorem comes with two conditions. One of them is that QR and ST are parallel. What is the other condition? Yes, Tiana.
Ma'am, I think it was over sides, like the sides being equal, so maybe like PR is equal to PT maybe.
Not quite. You're almost there. You're almost there. It does have something to do with QR. It does have something to do with QR.
QR and then is it being equal to ST?
Equal to, not ST. What of ST? You're right. There's an ST, but there's something missing in front of my ST.
No, I don't know.
I'll give you a quick refresher. Look up here. X is equal to, this side is equal to?
It's double.
Double, yes. So over here in front of ST, I need to say QR is equal to?
QR is equal to 14, so it's going to be double, and then it's like 28.
Okay. All right, yeah. You're correct, but what I need as an equation, I need to say QR is equal to 2 times ST. Okay. And then it makes it a lot easier for us to solve. Yes, let's substitute. Tiana, don't go away. Come back. Come back. Okay. Okay, so we're going to substitute. We know that QR is 14, which is equal to 2 times ST, which is X. Or have I got it the other way around? Oh, yes. Thank you, Teacher Nels. It's the other way around. So 2QR is equal to ST. Sorry, guys. It's the other way around. So I have to go 2 times 14 is equal to X, which is ST. ST is X. Now, yeah. Thank you, Teacher Nels. Thank you, Teacher Nels. It's the other way around, David. I'm sorry. I did it the wrong way around. Okay. All right, therefore, X will be equal to, tell me in the chat, guys, X is equal to what? Thank you, Lunabile. This one was a nice and easy one. Good. All right, so we've got the answer for X. We know that X is now equal to 28. How are we going to solve for Y? Does anybody have any idea what we can do? How are we going to do this? Who's got an idea? Okay. I'm going to give everybody a hint so we know where to start. Yeah, oh, Tandukolo, you know, guys, every time, Teacher Nels, every time I try to like help them out, they already know what to do. So I'm just like, what am I doing? What am I doing even? It's the F. Like, why am I even bothering giving you guys like clues? I should stop. Okay, good. Oh, David, you genius, you. Good. We're going to start with calculating for PQR. So we're going to go PQR plus 40 degrees plus 60 degrees is equal to 180. And we all know why this is, because I'm looking at the triangle PQR. I'm looking at this triangle, which means the reason here is going to be angles sum in triangle. Right, close. They're in there, no maths. I know, like, ma'am, don't help me. Don't help me. I'll do it myself. I love it. All right. So we know that Q or PQR is then going to equal to, Tiana has already given us the answer. PQR is equal to 80 degrees, right? And if PQR is equal to 80 degrees, that means that Y is equal to 80 degrees. What is my reason, guys? Why can we say that if this part over here is equal to 80 degrees, this one is also equal to 80 degrees? What is my reason? What am I going to write? Yes, Jasmine.
Because of the arrows?
Yes, what do the arrows tell us? What kind of angle is this one and this one, according to the fun angle?
Corresponding.
Yes, absolutely. Corresponding angles. But I'm not done, Jasmine. As soon as I say corresponding angles, what else do I need to say?
It's parallel.
Yes, which two lines are parallel though? You need to give me the parallel lines.
Line QR is parallel to line ST.
Beautiful. That's what I was looking for. Yeah. You guys are amazing. Jasmine, you are amazing.
Got a question.
Yes.
So when are we gonna do the formula with it and all that?
The formula for which one?
Midpoint. With the analytical part.
Okay, that is going to be on Monday. Okay, so on Monday, we're going to be learning about the midpoint theorem, and this is going to be part of it. Okay, well, not so much the midpoint theorem. In that one, I'm going to give you a straight line, a line segment, and I'm going to say, find me the midpoint. That's what it looks like in analytical geometry. Okay, so it's going to look a little bit different to what we're doing here. Okay.
Well, I keep asking about it because we doing that in school and I'm not getting any understanding of it. So
Okay. All right, my sweetie, it's fine. Listen, stay on the line with me after this, and you and I will have a chat about it. Okay. Okay. Okay, good stuff, my sweetie. All right, good. Okay, now we're going to take everything that we've learned and we're going to put it all together. And here's where we're going to start. Here. Okay, we are given that ABCD is a parallelogram. I go, Tiana, you can't just start with your. Now, they have told us that the shape we have in front of us is a parallelogram, right? So what does that tell us already from day one? What does that tell us before we even start the question? Think about everything that them telling us this is a parallelogram. What does that give us license to do, guys? A gift. Yes, that's it. Opposite sides are equal. So I can automatically say AD is equal to BC. And I can say AB is equal to DC. And then Notando, you are on point. AD is parallel to BC, right? Yes, David, opposite sides are parallel. And I can say AB is parallel to DC. What else, guys? What else? What else do we know? Opposite angles are also equal 100%. So if A is 120, that means angle C is also 120 degrees. All right, so we've got all of those kinds of things at play at the, beautiful. Up here is like the diagonals bisect. So we know that this midpoint over here that we're looking at, E, okay, cuts our parallelogram into equal parts. So this part here, 1, 2, 3, is equal to this part, 1, 2, 3. And this part over here is equal to this part. Okay, so when the diagonals bisect up here, that's what it means. It means the midpoint over there, or the part where they bisect each other, that's the midpoint, and that cuts each part of my parallelogram into equal parts. Okay, now the question says, calculate the values of X and Y. Give reasons for your answers. Tiana, where are we going to start?
Yeah. So then we're gonna start. I'm gonna start with X, but I don't know who's gonna do Y, but I'm gonna do X, right? So X
sure.
is 35 because of angles, because of alternate angles equal.
Beautiful.
And
alternate angles, but you must give me which two lines are parallel. Which two are parallel?
So it's AD and BC.
AD is parallel to BC. Beautiful. Okay, great. Tiana's she said she's only going to give us X. So I need somebody else to give us Y. Okay, can anybody think of how we're going to find Y? All right, we know that this is 35 degrees. Great. Anybody? I thought I wouldn't have to give a hint. Who was that? Who was that who said that? Alicia's like, Tiana will give Y. Makatse, what do you think? Oh, Motla. Makatse put their hand down. Motla, how are you?
I'm good, thanks, and you?
I'm good, thank you. Am I saying your name correctly, my sweetie?
Yes, it's Motla.
Mutla, okay, excellent. All right, how do we figure out what y is?
I was gonna say we're gonna say 120 minus 35, then we use alternating angles.
Okay, yes. Okay, we could, but that's not going to help us very much in this case because we don't know how much this part on its own is. Okay. We don't know how much that little part on its own is. But I'll tell you something. I'll give you a hint, Mutla. What am I mapping out as we speak? What is this?
A triangle.
It's a triangle. Okay, so let's think about what you know about a triangle. Have you got it now?
Yes, I've got it.
Okay, tell me what to write down. What do I write?
180 minus 120 minus 35.
Beautiful. And that is going to equal to y. What's my reason, Mutla?
Sum of angles of a triangle.
Good, good. I'm going to say sum of angles in a triangle. Beautiful. All right, now you need to find me y. Calculate y for me. Therefore, y is equal to?
It's 25 degrees.
Beautiful. Wonderful. You did that so beautifully, my sweetie. Mwah. Mwah. Well done.
Thank you.
Excellent stuff. All right, good stuff. All right, so there's one question that we're going to skip. Okay, we're going to skip 5.2. And the reason for that is because there's a information missing on the drawing and I don't want us to go there. Okay, now let's look at what's happened next, guys. The next question says, triangle ABC is congruent to triangle BDC. Oh, is triangle ABC congruent, and now look what I'm doing. Is triangle ABC congruent to triangle BDC? And if you've learned anything from Teacher Coco is that we need to map it out. Nothando, what do you think?
Yes, ma'am. We need to first map out the triangles we're going to use so we don't get confused.
Okay. All right. So let's start at A, you and I. So we're going to go A, B, C, and close it up. Okay. And the other triangle starts at
B,
and goes to
D,
D, C. And then we're going to close. Okay. Do you think that we're going to get what we're looking for from this triangle?
Yes, ma'am.
Okay, let's see. All right. If you're saying that this is actually congruent, we need to prove that it is. What is the condition that we're going to use for congruency?
Ma'am, side angle side.
Okay, let's see if you're telling the truth. All right, I'm going to go in triangle ABC and triangle BDC. Give me statements. Which side is equal to which side?
So, ma'am, AB is equal to DC.
Is equal to DC.
DC.
Okay.
Ma'am,
Question
it's
2.
given.
Okay,
And
good.
then,
It's given. What else?
Angle A, no, ma'am.
What's wrong? What's wrong?
Ma'am, we answered to say angle A is equal to angle C. But
is it?
no. Wait.
No. Okay.
No, it's not.
It's not. So there's something wrong with this congruency we've got going over here. Do you see it?
Yes, ma'am.
Because we haven't mapped out our triangles properly. Okay. So can we say that these two triangles are congruent?
No.
No, they're not. Okay. Because of the definition that we've got. No. And Esona is saying, is line BC common? Yes, it is. but my triangles need to be in a certain way. Notando, let's see what order do my triangles need to be in order for us to get them to be congruent. Okay, check where I'm going to start. I'm going to start at A, B, C, close triangle. So I'm going to go in triangle A, B, C, and triangle. Now, if I want to go in the other direction, if I started at the top in this triangle, where's the other top where I need to start at?
D.
D. Okay, we need to start at D, and then what did we do? We went
Downwards.
down. So we need to go D, C, and then
A.
Where are we going? To? So we need to start at top, go down, and then sideways.
B.
So D, C, B, and then close triangle. Now let's see if this is going to work. Triangle D, C, B. Okay, now your first statement is 100% correct, right?
Yes, ma'am.
Your first statement is 100% correct. You said that AB is equal to DC. We're on the same. We're on the same wavelength of understanding.
Yes,
right?
ma'am. And then BC is equal to CB common.
Good. We can say that BC is common. BC is common. Right. Anything else?
And then we can say we calculated Y as 25, and then we didn't calculate C, ma'am. If we could, can we calculate C? But we also we don't have B1.
We don't have this angle over here.
Yes, ma'am.
We know that this is 25 degrees.
25, ma'am. So if we add, can we add? No, we can't.
No, we can't.
Go there. No,
Okay.
we can't.
So the triangles that they've given us, are they ever going to be able to be congruent?
No.
We won't be able to do it. Do you see that, Notando?
Yes.
So
ma'am.
their premise over here, okay, is not correct. Either way, I'll show you what the triangles actually need to look like in order for us to get congruence. Okay,
Yes, ma'am.
it's not those triangles, it's this one. It's that one and this one, A, B, E. Those two, like
Are
that.
congruent.
Those two are congruent. Do you see that? Because
ma'am.
look at the information we have. I'm going to get 35 degrees and 35 degrees. Right. And then we know that AD is equal to
BC.
BC because of properties of a parallelogram. I need one more reason from you.
Ma'am, we can also say angle A is equal to angle C.
Good. We can say angle A is equal to angle C.
Oh.
That's going to give us angle side angle. Or we can even say that BD is
common.
BD is common. Do you see now that they've not arranged their triangles properly?
Yes, ma'am.
Okay, so can we say that these two triangles are congruent? These two over here? No, we can't.
No.
They're not. So there's no premise for this question. Can we state a condition for congruence?
No.
No. So we can say no condition because it's not congruent. Okay.
Yes, ma'am.
Excellent. All right. Thank you, Notando. I'm glad that you actually went into it and you started looking for the answer. I appreciate that. Awesome stuff.
No problem, ma'am.
Awesome. Okay. All right. Okay. So we cannot say that they're congruent, guys, because we need to make sure that we're naming congruence correctly when we're looking at our triangles. Okay. All right. Let's look at another midpoint theorem question. Okay. It says here that we've got triangle ABC, and triangle ADE. And the question says, calculate the size of angle ADE and give a reason for your answer. This is a nice and easy one. Does anybody want to tell us what is triangle ADE equal to, or angle ADE? ADE is equal to, any hands? Any hands? Chimwemwe, I'm going to come back, my sweetie. I need you to put a question, a solid question in the chat so I can see where I've lost you. Okay. Yes, Samuel.
It's 45 degrees.
45. Why?
Corresponding angles are equal.
Good. Corresponding angles. I'm not done. What else do I need to say?
DE is parallel to BC.
Good. Line DE is parallel to line BC. Good. Okay. Let's look at the next question. It says here, if AB is equal to AC, calculate the size of angle CAB. So now they're telling us that AB, this side over here, is equal to AC. It's equal to this side. And then they say, calculate the angle CAB. So we want that angle. Okay. What do you think we're going to do here, Samuel? Okay, I'm going to remind you. Remember in grade 8 and even in grade 9, you guys did the different types of triangles.
Yes, yes.
Okay. Can you name them? And Notando has completely given away the
Isosceles triangle.
good. There's an isosceles, yeah.
Scalene.
A scalene triangle. What else?
Equilateral triangle.
Good. Equilateral. Okay. Anything else?
That's all I know.
An RHS triangle. Don't forget the right angled triangle. Okay, cool. These are all of them. Right. Now, one of these triangles says something about these two sides being equal to each other. Which triangle is that?
Scalene.
Oh, no. Scalene means nothing is the same. That's what scalene means. It means no angles are the same, no sides are the same.
The isosceles triangle.
Yes, the isosceles triangle. The isosceles triangle tells me that this side and this side is equal. This side and this side. AB is equal to AC. But it also says something about the base angles. What does it say about these two angles here at the base?
Base angles of an isosceles triangle are equal.
That's it. So if B is equal to 45 degrees, what is this angle over here going to be equal to?
45 degrees.
45 degrees, good. So we know that both of these are 45 degrees. Now we need to write that down. Okay, I'm going to say angle ABC, which is this one, is equal to angle ACB, and they're both equal to what? To how much?
45.
Good, 45 degrees. What is our reason? What is our reason?
I only know base angles of an isosceles triangle are equal.
Okay, good. All right, so I think they're going to accept base angles of an isosceles triangle, but the wording that we're actually looking for is that equal angles of equal sides. Ooh, teacher Nels, help me out here. I'm forgetting what.
Angles opposite equal sides.
Good, thank you. It means isosceles, but it's angle opposite equal sides. Thank you, teacher Nels. Okay, angles opposite equal sides. Okay, so this is the condition that they're actually looking for. It's the properties of an isosceles triangle, but we say angles opposite equal sides. So what that actually means is if this is 45 degrees, then that side, and if this side is also 45 degrees, then the sides opposite them must be equal to each other. Okay.
Yes.
Now, can we find the angle A? If we know what that one is and what this one is, can we find the angle A?
Yes.
Okay, how do we do that? Everybody in the chat is already helping you out, by the way.
A is equals to 90 degrees.
Good. It's equal to 90 degrees. Let's see how we got there. We're saying CAB is equal to 180 minus, finish up.
90.
I minus 45 minus that 45 minus
45.
Minus 45 again, because we need to minus this one. What is my reason going to be, Samuel?
Sum of interior angles.
Good, of a triangle, yes. Angle sum in triangle. Right. Therefore, angle CAB is equal to how much?
90.
90 degrees. Beautifully done. Woo-woo! Well done. That's it. That's exactly what I was looking for. Well done. All right. Okay. I hope everybody's okay with this question. Okay, Chimwama, I know we lost you a little bit in the question above. We will come back to that. Okay, in just a bit. All right. I'm going to let everybody do this one by themselves. Okay, because this one is nice and easy. Okay. It says here that KLMN is a parallelogram. So they've already told us what we need to know. Now it says calculate the sizes of the interior angles. I'm going to say use X, using X. Okay, use X. Okay, I want you guys to think of all the properties of a parallelogram that will apply here and make sure that you're writing it out properly. I'm going to give you guys 3 minutes. 3 minutes. Let's see what you guys can do with 3 minutes to answer for the value of X and therefore the sizes of its interior angles, or the sizes of the interior angles of this parallelogram. You've got 3 minutes. Go.
Teacher Coco.
Yes, ma'am. Oh, please
yeah.
go out. Okay, yeah, I don't mind, but I can't block the question, Sifle, because everybody's writing. So we're gonna have to come to a compromise somehow. Okay. Sifle, if you want to take a screenshot, can I ask you to stay until the end of the lesson, and then I'll give you a chance to take a screenshot. Okay. All right, my sweetie. Cool. All right, this is the question we're doing now. You can pop the fire emoji in the chat when you're done. Okay. Mahlatsi has already given us the answer. Butle saying the letters are not the same, ma'am. I'm also asking which letters now, because there's an X here and there's an X here. I'm not sure which letters. Oh, I know what she means. I know what she means. Teacher now, this is what she means. The triangle, I mean, the parallelogram is called KLMN, but the parallelogram in the drawing is called PQL.
Oh, now I see.
I see it now. KLMN. Thank you. Thank you, Bushe and Gift. Okay, Zamanzini's got an answer for us as well, but Lachuma's answer comes with a question mark. I don't know how. Okay, great. For those of you who have found what X is, the question didn't ask for X. Alusha. Okay, the question didn't ask for X. What is the question asking for? Make sure that you're not just solving for X. Okay, see, Tandukolo's getting the idea. Okay, now Tandukolo has also only gone halfway because the question says, calculate the sizes of its interior angles. It didn't say which ones. It didn't say which ones. It just said interior angles. So we now have to look for all of them. Look for all of the interior angles, guys. Hey, Notando's getting there. Okay, cool. All right. I feel like I'm speaking to like 5 people in the chat right now. Zamanzini is like literally the only person answering. But again, as I said, we're supposed to be putting a fire emoji in the chat when we're done. So Notando and Zamanzini is doing the work for everybody and everybody's just copying your answers. With David as well, Reabetswe as well. Oh, Makhatsi, are we sure that L is equal to M? I don't know about that statement. That's it. Okay, thank you, Makhatsi. There we go. You see, Alicia, you picked on Tiana and now she's sleeping. That's what happened. All right, let's have a look at our answers here quickly. All right, what do we know about these two angles? Because we know that this thing is a parallelogram, what do we know about the opposite angles? That they are what? They are equal. That's it, Tiana. I thought you were sleeping, but I see you're wide awake. That's it. They are equal. So I'm going to make the statement. I'm going to say angle L is equal to angle N. And I can now, this is the part, I can't remember who it was in the other lesson who said, ma'am, why can't we just say properties of a palm? Now I can use the statement, properties of a parallelogram, because now they've told me. And then I have to say opposite angles are equal. Okay, I need to make sure I'm saying both of those things. Okay, then I can write down my equation. I can go therefore 5x, I'm just skipping space, guys, because I'm running out of space. 5x minus 12 degrees is equal to 3x plus 18 degrees. And then we just solve for x. I'm going to take my 3x over to the other side and it will become negative. My 12x will, my negative 12 will come over and become positive. I will end up with 5x minus 3x is equal to 18 degrees plus 12 degrees. So 5x minus 3x is 2x, which is equal to 18 degrees divided by 12, plus 12 degrees, not divided by, plus 12 will give us 30 degrees, right? So I'm going to divide both sides by 2 to 15 degrees. Now, I agree with you guys 100%. X is equal to 15, but that's not what they asked me for, guys. That's not what they asked me for. They asked me to calculate the interior angles, right? So I'm going to start with L. I'm going to go L is equal to 5 times 15 degrees minus 12 degrees, right? I know that 5 times 15 is 75. 75 minus 12 is in fact 63 degrees. I need to make sure that my calculations are correct because these two things are supposed to be equal to each other. This is how I'm going to check. I'm going to go angle N is equal to 3 times 15 degrees plus 18 degrees, right? And that is equal to 45 plus 18, 55, 63. Indeed, they are both equal to 63. So L is equal to 63 degrees and N is equal to 63 degrees. But now lies the issue of angle K and angle M. Okay, but we also know that the interior angles of a of a quadrilateral are equal to how much? How much are they equal to? That's it, Lunabile. I knew you knew, guys. I'm asking a dumb question. I knew you guys. You knew. Cool. So I can then say that angle K is equal to angle M for the very reason that we put up here. This reason, the properties of a palm, properties of a parallelogram. Okay, properties of a parallelogram, and also that the opposite angles are equal. And I see Luyanda saying, ma'am, can we not use fun? No, because where are we going to draw the fun here? We don't know what y is. We don't know what y is. So we don't know what either of those are. Okay, but I'm going to name them both y because I know that they're equal. So this is y and this is y. So I'm going to add up all my sides of my parallelogram or my quadrilateral. Okay, so I'm going to go 63 degrees plus 63 degrees plus y is equal to 360 degrees. And then I can just say the interior angles of a quad. The interior angles of any quadrilateral will give us 360 degrees. And then we just need to do a little bit of manipulative maths. Okay, y plus y will give us 2y on this side, 2y. And then I've got 63 plus 63 will give us 126. So I'm going to take this 126 over to the other side. So I'm going to get 360 degrees minus 126 degrees. Right, let's finish up. Oh, let me see, what did I do here? Okay, let's move this down a little bit. Okay, yeah. That's equal to 126 degrees. So I can then say 2y is equal to 360 minus 126. Okay. No, Tanukolo, it doesn't exactly have to look like mine, but remember, it needs to be in a way that makes mathematical sense. Okay, so I'm going to go 360 minus 126 will give us 234 degrees. Thank you very much. And then I still have to divide by 2 on both sides. Divide by 2. Okay. Therefore, y is equal to 117 degrees. So that tells me that K and M are equal to 17 degrees each. All right. Give me a thumbs up if you were able to do this exercise. Okay, were you able to get the answers that are on the screen? Give me a thumbs up if you were able to, a thumbs down if you struggled a little bit. Okay. Amber's like, somewhere in the middle, ma'am, somewhere in the middle. Kelafuma says you struggle getting why. I can see why, but remember, we need to leverage what we know about parallelograms. After all that time we spent proving parallelograms, guys, I will. Okay, we need to go learn our properties of You can tell that there's 8 minutes of class left because teacher Coco's maths is just, I mean, now I'm saying the maths. The English is just, Gift is like, I got the answer, not the answers, which means Gift calculated for X and forgot to do the rest of it. I know, Tandwikolo, proving parallelograms was hectic, I know. All right, so this does take a little bit of practice, guys, but as soon as you get used to it, it gets so much easier. And I'm going to warn you now, I'm warning you now. Parallelograms come up when we look at analytical geometry. So you must know your properties, not parallelograms, quadrilaterals. Okay. Chimwemwe, that's the thing. When you look at it, okay, if you think about it, ma'am, teacher Coco, said that I'm the one who told you to use X. So if I hadn't told you to use X, you couldn't possibly have been solving for X. Okay, so we need to make sure that we know. I know, Tiana, I'm so sorry. Tiana's like, oh, maths teachers say things will get easy and it just gets worse. Tiana, the more you're used to it, the easier it becomes. Okay, all right. We're going to look at one last question, and we're not going to spend too much time on it. It's a pretty difficult one, I think. Okay, but we're going to try our best to wrap our head around it, because today is quiz day, and I want you guys to go try the quiz if you can. Okay.
What's going to be on the quiz today? Gifted is asking.
Okay, it's going to be the quadrilaterals that we did and the proofs around them and the midpoint theorem. Okay, quadrilaterals and midpoint theorem. Okay, which should be nice. I think today's quiz is going to be quite nice. Okay. Mirilla saying, what are we doing next lesson? We're doing analytical geometry. Tiana, if you fail the quiz, then you can just do it again because it's not for marks. So it's not that deep. All right. I love how Michelle is like, maths is so nice with tears, with the tears face. Oh, Tandikolo, I'm sorry. You can do it again. You can do it again. All right, let's read the information we've been given, guys. Okay, that's fine. That's fine, Tandikolo. That's why I'm like, come to the boot camp. We show you how to not make those kinds of mistakes. Okay, so the question says, yes, Alicia, it is. In the parallelogram ABCD, AB is equal to 50 millimeters, BC is equal to 80 millimeters, and BAD, so this whole angle, BAD, this one over here, is equal to 110 degrees. E is at a point on AD such that AE is equal to AB, and BEC, this one here, is equal to 75 degrees. All right, so let's look at what we've got here, because truly what we're doing here will not be will not take into consideration. Alicia says, will you be able to see that we redid the quiz again? Yes, Alicia, and it won't matter. The mark at the end will matter. Okay, so the first question says, calculate the value of CED. So we want to calculate for this angle here. CED, this angle. Okay. Now, we've got to think a little bit outside the box. Okay. Ah, Alicia, I love to hear it. Okay, does anybody have any idea? What do you guys think we can do first? Who's got an idea? Anyone? Okay, I'll give you guys a hint. It might not have anything to do with quadrilaterals, but think about all the geometry that we know. Jasmine, what do you think?
The two lines, right, indicate that the two angles, not the angles, the two sides are the same, right? So the other end of where line AE is, right, if we had to dissect it, would also be 50 mm, right?
Yes, absolutely, 50 millimeters. What does that tell us?
That it is...
Okay, if these two sides are equal, what does that tell us about B and E?
Side angle side.
Okay, not so much side angle side. Tiana's written the correct answer in the chat. So has Akleh. Look at this. Look at, good, it's an isosceles. So what does this tell us about this angle B and this angle E here?
That it's equal.
Good, that they're equal. That the base angles are equal. How are we going to calculate for them, Jasmine?
Angles of a triangle.
Good, angles of a triangle. So what I'm going to do is I'm going to name this one X. And if this one is X, this one is also X.
That is also X. So
okay.
180 degrees minus 110 is equal to 70. So that means the two small angles is 70 degrees.
Good. So I'm going to say 2x is equal to 180. So I'm going to say 2x is equal to 70 degrees. Therefore, x is equal to how much?
35 degrees.
Good, 35 degrees. Oh, Tiana, you're such a rock star. Now we know that these two
Tiana.
angles are 35 degrees. Sorry, Jasmine. I'm sorry, my sweetie. I meant, you know what I meant. I'm sorry. I didn't mean to. It was a mistake.
It's okay. It's fine.
I'm so sorry.
You're the
I meant
first person to
Jasmine.
call me the wrong name today.
Jasmine, listen, you are my favorite Jasmine. Of all the Jasmines, you are my favorite Jasmine. Please. I'm very sorry, my sweetie. I'm so sorry, my sweetie. Yes, Jasmine. Jasmine. Okay. All right. So we want this angle over here. We want this angle over here, Jasmine. How do you think we can calculate for it?
Well, assuming there'll be angles on the straight line there, because the line AED is one long line, so it's exterior angles, isn't it?
Yes. So we're only going to use these angles here. Okay. Again, let's call this part y. So how would I figure out what y is?
Y would be 180 minus 35 plus 75.
Good. 180 minus 35 minus, okay, I'm going to minus all of them. Okay. Therefore, y is equal to
also 70 degrees.
70 degrees. All right. Look at that. You did so wonderfully. Thank you, Jasmine. You are amazing. You are the best Jasmine that I know.